Good morning, we're on to lesson 9 notes, which is applications of sinusoidal functions. These are your very last set of notes to go through in the last video you'll have to watch. I'll go through it quickly here. I'm just going to go through the first example and we can look through the second one and we'll go from there. Okay, so one of the most common application questions for graphing trigonometric functions involves Ferris wheels. We talked about an example of that last day as well. Since the up and down motion of a rider follows the shape of a sine or cosine graph. So here's the question. A Ferris wheel has a diameter of 30 meters with the center 18 meters above the ground. It makes a complete rotation every 60 seconds. And we want to draw the graph of one complete cycle, assuming the rider is getting on at the lowest point of the Ferris wheel. So looking at that, there's a lot of stuff going on. What I always like to do is draw a diagram first. So here's my Ferris wheel, and it tells me that it has a diameter of 30 meters. So remember, diameter is all the way across. Here's your center. So I know the diameter from here to here is 30 meters. And then it says the center is 18 meters above the ground. So here's my center. So I know this portion here is 15 meters, right? It's half of your radius. And it's telling me that the center is 18 meters above the ground. It makes sense. It means that the center of your Ferris wheel is in total 18 meters above the ground. So here's my ground here. Which makes sense. You're not going to have your Ferris wheel resting right on the ground or it's not going to be able to roll. So that means it's up a little bit on a stand. And it's up approximately 3 meters above the ground. Because then you have 15 plus 3 gives you the 18 meters that the center is raised up. So that's kind of the diagram of what my Ferris wheel will look like based on that information. Then the next thing I do before I graph is I like to create a little table of values just to kind of sort the information in my head. So T is for time, H is for height. And I like to kind of see what the pattern will look like. So at time 0, this is when my person gets on the Ferris wheel and they get on at the lowest point. So that's going to be here, is where they get on. So you can see the height at that point is 3 meters. Okay, then the next bit of information, it tells me it does a complete rotation every 60 seconds. So that means my person gets on here at time 0, and after a full 60 seconds, they complete a full rotation and get back here. So I know after 60 seconds, they're going to be back at point 3. We can do a little bit more information. Halfway is here. So I know at 30 seconds, they're actually going to be at the highest point, halfway between the full revolution. So after 30 seconds, I know they're going to be at the highest point, and I can figure out how high that is. This is 30, plus I have an extra 3. So at the highest point, they're going to be at 33 meters. Then they're going to continue going on, and they're going to get to the lowest point after 60 seconds and be back at 3. So basically, every 30 seconds, I can follow this pattern and continue it on. And it repeats like this over and over and over again. So that's how I like to set it up, just to organize the information. It's just reading it is a little bit tricky to decipher what's going on. So draw a diagram, that way you can get your information. Do a little table of values so you can see what it looks like. So I'm now going to draw my graph using that information. Here's my height in meters. And here's my time in seconds. Okay, so I know at 0, my height is at 3, so that's going to be about here. At 30, my height is at 33. Let me see if I can fit this on here. 30, I'm at, mark it here, my thing's a little too big, is at 33, which is about there. Then at 60, I'm back down to 3 again. So you can see this is what your curve starts to look like. So let's draw this out here. It's going to follow a sinusoidal curve or cosine curve. So we're going to go up to a gentle curve to the top, And then do a gentle curve to the bottom, and that's just going to repeat over and over again. So that's an idea of what the graph will look like. And it says find the cosine equation of the graph. So we could technically type in those values into your list, L1 and L2, and do a regression on it, or we can just do it by hand. So I'm going to do it by hand just to get some extra practice in. So in order to get your function, first of all, what I like to do is I like to draw the midline. So I can see my graph goes between 3 and 33. So that's a difference of 30. So I need to have 15 above here, which will bring me to 18. So this is my midline here. Take away 15, I get 3. Add 15, I get 33. That's exactly in the middle. So it's going to help me with my equation. Now we can figure out our amplitude. So if you look at your midline, here's my amplitude. You can see that it is 15 above your midline. So I know my A is 15. And what you'll notice with the question is this matches your radius of the original question. My diameter was 30, my radius was 15. So your amplitude is actually your radius of your circle. Your vertical displacement is where your midline is at, which we determined was at 18. And you'll see that matches with your maximum, or your center height, sorry. So height of the center of your Ferris wheel. It's nice to look off the graph and get that as well. Now we have to figure out period. So looking at this graph, I can see one full revolution was completed in 60 seconds. So my period is 60, but I'm not putting that into the equation. I have to make it into the b value before I put it in my equation. So remember to figure out your b, it's 2 pi divided by your period, and I'm going to simplify the 2 over 60, so it becomes pi over 30. Is my b value. Now I have my a, b, and d, and I can write my equation. It's a cosine equation, so remember the general form is this. So now I just need to plug in my values. My a is 15. My b value is pi over 30. And my d value is a positive 18. And then I'm going to be very careful and see if there's a reflection. When you're doing your cosine value, usually it starts at your highest most point. But you can see it's a reflection, it's flipped upside down, and it's starting at its absolute lowest point. So that means it is actually a negative in front. So that's your equation of your line. Okay, now we can answer some questions. It says, what is the height of the rider at 52 seconds? So that tells me my time, my x value. 2 ways you can do this. If you want to graph it in your calculator, then you can type it into your value and see what your y value is then. What I did is I just did it algebraically. So it's telling me my t, or my time, which is down here, is 52. I wrote it slightly different. I used h and t in the notes, which is probably more accurate based on the context of the question, but I wouldn't mark it wrong either way. So if I want to find the height, all I have to do is substitute in 52 instead of my theta, or my t, and type that in my calculator to get my answer. So I'll show you how we can put that in real quick. So we have negative 15. Make sure your calculator's in radian mode. Before you do this, you're going to get a different answer. Cos, and then I have pi over 30. I'm going to put an extra bracket here. You might not need it. Sometimes I like to err on the side of caution. Pi over 30, and I'm timesing that to 52. And then I'm going to add 18. And you can see your height becomes 7.963. If I round to the nearest meter, that's going to be 8 meters. And then that question is done. Or I said in the notes, you could graph it and use the calc value button, and you should also get 8 meters. Then it says, at what time is the rider at 20 meters? So now it's telling you your y value, or your h, is 20. I showed you how to do this algebraically as well. You can look in the notes and see that method. It's a little more complex to solve it algebraically. So what I would do is I would graph your equation into your calculator. So we have negative 15 cos pi over 30. I'm going to put an extra bracket in there just in case. Times x plus 18. I'm going to change my window before I do anything. I can see my x values or my t values. We go up to 60. I'll go up to 90 though, so that's fine. And my y goes all the way up to 33. So let's make this 50 instead. Okay, so here's my graph. And then I'm going to graph my y2 is 20. And then you just need to find your point of intersection. At what times is the rider at 20 meters? In the graph, I've only gone up to 60, so I don't need to do every single one. Actually, we should have probably done 2 at least. This guy and this guy. I think I only showed one in the calculator, but we did the first one. Okay, so then you're just going to go into second calc, and we're going to find the intersect. And hit enter, enter. I'm going to find the intersect of the first one here. Oh, did I miss something? I think I did. Second calc, intersect, first curve, second curve, and then my guess. I must have hit it too many times. Okay, so I get 16.27, etc. is my first time when it reaches 20 meters. I should have also figured out the second point of intersection here because the rider is also at 20 meters at that time as well. So when I do that, you see your t will equal 16.3 seconds when I round it. We had found the point of intersection, and it was, let me see here, 16.277. 20. And from that, we get our time is 16.3 seconds. And then you can do the next one as well to figure out your next point of intersection. And that's it for this one. You can use combination calculator or algebraic if you like, but it's a different way of thinking of it. And always draw a diagram to help you analyze your information. And I definitely missed you guys over these last couple months, so I hope you have a great summer if I don't end up seeing you.